Hello friends and welcome to another lecture of Big Data series, and this is the fourth lecture of this series, and today we are going to focus on Hadoop components basically. So when we talk about the Hadoop ecosystem, there are a lot of components which come under the umbrella of Hadoop, and we will cover few of them today. So we'll describe what is the Hadoop pipeline, how does the pipeline of Hadoop looks like, or not even Hadoop, we will look in general how the big data slash data processing pipeline looks like. We will look at some of the components, the most popular components of Hadoop basically, which will be like Scoop or Flume, HDFS, HBase, MapReduce, Pig, Tableau, Hue to name a few. So let's get started. So first of all, let us understand what is a Hadoop pipeline. So when we talk about Hadoop pipeline or a big data pipeline, that pipeline has certain steps. It starts from data ingestion, as you can see here. So data ingestion is the part from where actually the data is ingested in the system, is basically inserted into the system. And once you ingest the data, then you need to have a storage medium or a storage place where you will be storing the data. That comes with the data storage part. And the third one is data processing. So now that you have the data stored, now you will want to process the data, right? You will want to get some good analysis out of that data. So as part of the data processing, you basically cleanse the data so that you can actually run some queries on it. And then as part of the data analysis, you run those queries. Now these queries can be your simple SQL queries as well and complex OLAP queries as well. So as part of the data analysis, you basically run different analytical queries onto the processed data. And once you have the result of those queries out with you, you will want to present that data on some sort of a visualization tool or some sort of a dashboard. So that's a traditional, a very vanilla data pipeline is where you first ingest the data, then you put that data into a storage medium. Then you pick the data from the storage medium and you process the data, basically cleans the data. And once the data processing is done, then you run analytical queries on the processed data. And the output you get from the processed data is something which you present on a visualization tool or a visual dashboard. Now, for each of these different processes, Hadoop provides certain tools, and we will cover each of these particular steps, and we will cover what all tools are available in these steps. Like we will have some tools for data ingestion, some tools for storage, processing, analysis, and visualization. Then apart from that, there are two more different categories of tools which are used in a Hadoop pipeline, which are monitoring and management solutions or tools and some scheduling tools. So as you see that you are performing multiple steps in this pipeline, you will need some sort of a monitoring solution, right? To monitor the progress of the job or to fix things or to create different reports as to how the whole data processing is happening. So for all of those needs, you will be using some sort of monitoring and management tools. And when it comes to scheduling, you will want to schedule your whole pipeline, right? Let's say you want to run this pipeline every 24 hours or nightly builds. So for those kind of scenarios, you will need some sort of a schedulers which can schedule the jobs which will run at a certain time and it will run the complete pipeline. Those tools will come under the scheduling tools. So we'll cover all of these different steps and the tools applicable to these steps in the coming slides. So let's move forward. So first of all, let's talk about the data ingestion tools. And let me set the expectations right in this session. So in this session, we will try to cover a very generic idea about the tools. And then in the upcoming lectures, we will go deeper in each of these tools. So in this slide, we are just going to understand what is the tool, why it is used, and a very simple feature part of it. What are the basic features of that particular tool? So it will be very simple lecture. We will not go in too much detail in this lecture when we talk about the components of Hadoop ecosystem. So the first component we are going to talk about is Scoop. So Scoop is primarily used when you want to transfer the data from your relational database systems to Hadoop, right? You have a lot of data available in your database systems, and now you want to run analytical queries on that data. So you need to move that data into the Hadoop ecosystem, and Scoop is something which can be used to move that data to Hadoop ecosystem. And it's compatible with all the popular relational databases like Oracle, Postgres, MySQL, to name a few. The next tool is Flume. Now, Flume is a tool which is used for data ingestion into the Hadoop ecosystem, and the data goes straight into HDFS. Now, that data can be real-time data, the data which comes at a high frequency. Remember, in the first lecture, we talked about the volume, variety, and velocity, right? So if the data is coming at a very high speed, like log data or streaming data or social media tweets or IoT sensor data, so that data is coming in real time. Every second, let's say hundreds or even thousands of records are coming in. So that's the kind of data which we treat as streaming data. So Flume is something which can be used to copy the streaming data from the various source systems and put that data into HDFS. If you remember, HDFS is something which we talked about in the previous lectures, which is basically the distributed file system of Hadoop. The third component is Kafka. Now, Kafka is also a streaming platform which you can use also as a pub-sub model or a publish-subscribe model. Now, what is publish-subscribe model is something you can think of it as a middleware layer. So if you have a producer system and if you have a consumer system, now producer system wants to transfer some data to the consumer system. So it needs a middleman, right? It needs somebody in the middle to actually transfer the data, and that's what Kafka can also be used as. It can also be used as a stream ingestion platform. So you can use it as a stream ingestion platform. You can use it as a pub-sub model as well, and it can also process records in real time. So that's about the data ingestion tools. So we talked about Scoop, Flume, and Kafka. Now let's move ahead and talk about the data storage tools. Now, HDFS is obviously the primary data storage tool in Hadoop, and we have talked about this a lot in the previous lectures as well. So I'm just going to repeat what I said earlier, that it's the primary data storage for Hadoop applications. It's distributed in nature, and it also replicates the data to multiple nodes, so your data is always resilient. You don't lose the data easily, and especially designed for huge data sets. The second data storage is HBase. It's an Apache project and it's an open source platform, and it's basically a non-relational distributed database. Now, if you remember in the previous slide, we talked about Scoop, which can be used to transfer data between relational systems and Hadoop. So relational systems are the systems in which you see tables and columns, and non-relational systems or non-relational databases are the databases in which there are no tables and columns. Rather, there are documents or there are key value pairs. So the data is not structured in the way you see in an RDBMS system. It's different than RDBMS. It's in fact counter to relational data. Non-relational data is the data which does not have a fixed schema. It runs on top of HDFS. At the base of it, it's still HDFS. And HBase can host very large tables. And we are talking about huge tables like billions of rows and millions of columns. So you can understand the kind of capacity HBase has in terms of storing the data in very, very large table. And it can still provide you real-time access. So these are the two storage tools, which are HDFS and HBase. Let's move forward and understand the data processing tools. So the first data processing tool is something, again, we have discussed quite heavily in the previous lectures, which is MapReduce. So as you know, that MapReduce is basically a software framework which you can use to write applications which can process the vast amount of data in parallel. So the whole value proposition and the whole benefit of MapReduce is that it's distributed in nature, it supports parallel computing, and it's very, very fast as well as reliable. The next one is Spark. Now, Spark is also a processing tool which can also be used as a unified analytical engine when you have very large scale data and you want to do distributed processing on the data. And at the same time, if you also have a need to do some sort of machine learning on that data, then Spark is the tool to go. It's hugely popular in the big data community. It's the go-to tool for doing any processing as well as some basic machine learning on the data as you process it. So Spark is something very important and popular when it comes to data processing tools. The third one is Ignite. Now, Ignite is a bit high level, I would say, and pretty new. It's again a horizontal, scalable, fault tolerant, and distributed. So you can see it has all the properties which you see in MapReduce and Spark, and it can also process the data in real time. It can even go to terabytes and even petabytes, and all the transactions happen in memory. So it's lightning fast, but it's a bit advanced concept. And I'm mentioning this here because I just wanted to cover all the concepts and all the tools here so that you don't miss any important tool. Okay, that's about data processing. So we talked about Spark, MapReduce, and Ignite. Next comes the data analysis tools, and when it comes to data analysis, we are talking about running the analytical queries now, the SQL queries, right? So you have Hive, Pig, and Impala. So let's take all of them one by one. Let's talk about Hive first. So Hive is, as it says on the slide as well, it's basically a data warehouse infrastructure tool which you can use to process structured data using MapReduce as the base. So you can see that if you are processing the data with MapReduce, Hive is something which you can use to run analysis queries on that data. It also facilitates it supports the SQL structure. So you can use the same SQL syntax which you are comfortable with coming from Oracle, Postgres, MySQL, etc. So you can use the same SQL syntax to write and read the data from really wide and huge data sets. Next comes Pig. Now Pig is another tool which is used for analyzing large data sets which consist of high-level language for expressing the data analysis programs, and it also supports MapReduce, and it's quite similar to Hive, but again it's a bit smarter than Hive, I would say. So Pig is a bit smarter and bit newer than Hive, and again I'm mentioning this tool so that you don't miss this tool, but Hive is still very versatile and it can solve most of the challenges, and you should always take a calculated analysis to see if you want to use Pig, and we will talk about those details in the upcoming lecture, so don't worry about that. Next one is Impala. Impala is super powerful because the biggest advantage of Impala is that it has massive parallel processing powers. So it is also an SQL engine because basically we are talking about analytical queries, right? It's SQL queries. So it is an SQL platform, but at the same time, it can distribute your SQL query on a huge amount of data to multiple machines. So it becomes really powerful. It can run the query in parallel on multiple nodes at the same time, which makes it a really high performance tool. So if you're looking at a comparison of when to use Hive, when to use Pig, and when to use Impala, don't worry about that. We'll cover all of those details in the upcoming lectures when we'll go deep about these tools. But like I said, Hive is pretty much good for any kind of SQL analytics which you want to run. Pig is super fast, very new, and Impala is when you have really complex data structures and you want to process the data in a highly distributed fashion. Next comes the data visualization tools. Now there are three popular data visualization tools. First one is Hue. Now Hue is open source tool. So you basically, when you install Hue, you basically get a web based interface in your browser, and it has an interactive query editor as well, which you can use to interact with the data warehouse. And obviously, since we are talking about visualization tools, you can build the charts and the reports and the dashboards and the bar graphs and whatnot in Hue. Next one is Ambari. Ambari is also gaining quite a lot of popularity nowadays when it comes to doing data visualization, and it's basically designed mainly for the system administrators to do the monitoring and management tasks. So it's not exactly made for developers, rather it's made for the people who are managing the system, who are managing the Hadoop ecosystem. They can use this particular tool to provision or manage or monitor the complete Hadoop cluster. And the last one is Tableau. Tableau is again hugely popular and it also is treated sort of an industry standard in most of the organizations when it comes to generating reports and creating graphs and pie charts and bar charts, etc. It's a very powerful tool, but the downside is that this is not open source. So it's a licensed tool, so you have to pay for it if you're using it professionally. So we covered all the steps of ingestion, the storage, the processing, the analytics, and visualization. Now there were two more bars if I go back to this particular slide. So we covered the data ingestion, the data storage, data processing, data analysis, and data visualization. Now we will cover the monitoring and the scheduling part as well. So let's go back to the scheduling part. So there are two popular scheduling tools, which are Oozie and Airflow. Airflow is extremely popular in the machine learning community as well, and for building any kind of orchestration workflows. And Oozie, let's first talk about Oozie here. So Oozie is a workflow scheduler system which you can use to create jobs and manage those Hadoop jobs. For example, if you want to have a requirement where you want to run a weekend job, which should run every day Friday at 7 p.m., then you can use Oozie to schedule a job on the Hadoop cluster, and the Hadoop cluster will automatically trigger the job, and whatever code or steps you have specified in the job will be executed at that time. Next one is Airflow, and like I said, Airflow is very popular and it's still gaining a lot of popularity as we speak. It's an open source workflow management system. You can think of it as a flow chart basically, if you know flowcharts where you have a lot of processing box, input box, output box, decision box. Let's say if you want to make a tea, right? So you can basically list all the steps of making a tea into a flowchart. That first you will boil water, then you'll put the tea bags, then you will put milk, etc., etc. So in Airflow, you can actually build that kind of a whole complete flow chart with all the decision boxes, all the parallel processing, and then you can execute that Airflow. So let's say if the first step of Airflow says data ingestion, the second step says data processing, third step says data analysis, and if you execute the Airflow, the complete Airflow engine, then it will run all the steps one by one for you. So that's the power of Airflow. And it has very rich user interface, so you can actually see which step is being executed, which step has failed, which step has passed, etc. So this is what we all talked about in a nutshell, right? So when it comes to the storage, we have Hadoop HDFS. Yarn is something which we covered in the last lecture, so I'm not going to repeat that. It's basically resource management or resource manager, basically. On the left-hand side, you see for coordination and management, we have Ambari. Zookeeper is also pretty popular, but we will cover that in the coming lectures. It's something not exactly tied to the big data system or ecosystem, but this is also which is something which can be used for coordination and administration. And we have always Ambari here. On the right hand side, we have Oozie and Airflow as the scheduling task. Now, when it comes to processing, we talked about Ignite, Spark. For stream processing, we have Kafka. For SQL over Hadoop, if you want to run analytics, then you have Hadoop and Impala. For NoSQL, you have HBase. For data piping, you have Flume and Scoop. For machine learning and still data processing as well, we have Spark and Spark MLlib. And for scripting, we have Pig. So this is in a very gist of what all is possible in Hadoop ecosystem. And if you actually look on internet, you might see more and more components popping up into this. So the whole power of Hadoop ecosystem comes from all these components, and you can also ingest more components into this ecosystem as per your needs. So you might see a different representation of this ecosystem with some additional tools and some tools removed if you look on other tutorials. But that's not a thing to worry, since we will cover all the most important components of Hadoop ecosystem in this tutorial series. So to summarize, we discussed what is a Hadoop pipeline. We discussed the 5 different steps of Hadoop pipeline. We described all the components which are used in ingestion to storage to processing, analysis, visualization, scheduling and monitoring, and administration as well. And those tools range from Scoop, Flume, HDFS, HBase, MapReduce, BigHive, Hue, Tableau, etc. So hope this lecture was helpful, and please share your feedback in the comments, and we will love to listen from you what you want us to improve upon, and what extra things we missed, what are the things you liked, what are the things you disliked. So please let us know in the comment section, and we'll meet in the next lecture. Thank you.